Today we're going to be talking about the correlation coefficient. This is a number that falls between -1 and 1, and it's going to tell us two things about a scatter plot. It's going to tell us how strong and the direction that those two variables have in reference to each other. Now, the correlation coefficient is analyzed based off the residual, which the residual is just the distance between the scatter plot and the best fit, which you will learn about that a little bit in the residual video. So when we're talking about this correlation coefficient between -1 and 1, we're going to be looking at the strength first. So if I think about it on a number line, I have -1 to 1. The closer my numbers are to -1 and +1, the stronger it will be. Okay? And as I move closer to 0 on that number line, that means that the weaker it's going to become. So no correlation is when that value is 0. So the closer my values are to 1 and -1, the stronger they are. The closer my correlation coefficient is to 0, the weaker they are, and eventually will be no correlation. Now the next thing that I'm going to talk about is direction. So direction is going to be basically what direction are my values going. So if I have a negative number, then of course it's going to be going in a negative direction for my scatter plot. If I have a positive number, that's going to be going in a positive direction for my scatter plot. So remember, positive means that my x and my y are both increasing, and negative means my x is increasing while my y is decreasing. So two things that correlation coefficient tells us: it is a number, it tells us how strong my scatter plot is between those two variables, and the direction in which they are moving. Now we're going to go on to some examples, and we're going to look at how to use Desmos in this situation. Alright, so just like you've done previously with a scatter plot, or maybe you haven't done it before, but in Desmos you're going to click the plus button to add a table, and you're going to put in your x and y values. Now, depending on whether you're doing a line of best fit and finding the correlation for that, or exponential best fit, depends on which formula you use. But ultimately what you're going to be looking for is you're going to be looking for the R value. The R value is what represents the correlation coefficient. You will see an R squared, but the R squared means something else in this situation, so we are only going to be looking at the R value. Okay, and that R value is the number that we're going to compare. So a few examples here. It says the table below shows the amount Jeremiah plans to receive at the end of each year from one of his investments. What is the correlation coefficient, so the R value, for which this statement best describes the linear relationship? So I'm going to put this into Desmos because it's given to me as a table, which I've already typed over here, but again I would have gone to the plus and I would have added my x, y values and my y values. So the key here is it is a linear relationship, so we're going to be looking at a scatter plot that has some linear direction and linear pattern. So in order to look at that scatter plot, I'm going to, on the blue side of the table where that column is, I'm going to select that zoom option. And when I click that, it's going to show me my scatter plot. And I'm going to wind up typing in my linear formula. So that linear formula is y1 squiggle, which means similar, mx1 plus b. Now, the reason I used an x1 and a y1 is because that's what it was labeled in the table. So I'm going to be looking at that R value. And that R value that we are getting, that correlation coefficient, is R equals 0.9895. And that tells me a couple of things. It tells me that this is definitely a strong relationship. I know it's a strong relationship because I have 0.98. Okay, that 0.98, if I think about it on a number line, is close to +1. The other thing that I know is I know that it is positive and it is on that positive side. So I'm just going to draw a quick number line and kind of plot that point so you can see it visually. But you can see that point is close to 1, so therefore it is strong, and it is on the positive side, so it is going to be positive and strong, which makes the correct answer D. Alright, so for number 2, it says the table below shows the scores of 7 students on a math and science test. What is the correlation coefficient for the linear data? So I'm going to erase that table and I'm going to type in my values. I'm going to definitely make sure that I'm careful, making sure that I don't make any mistakes, because one small mistake can completely change my line of best fit and my scatter plot and my correlation coefficient. Now, this did say that it was a linear data relationship, so we are going to use our linear formula. Finish putting this in. And I'm going to go to my next line, and I can hit that zoom button to see the scatter plot. And you should see that this one is much more scattered than the other one. It's not as close as the compact relationship, but I'm going to type in Y1, that squiggle, which means similar, mx1 plus b. And for this one, my R value is positive 0.63. So we know it's that positive relationship, but what does 0.63 mean? So I wouldn't consider 0.63 a strong relationship, nor would I consider it no relationship. I would consider this a very moderate relationship. If I look at it on the number line, 0.63 would fall between 0 and 1. Yes, it's a little bit closer to the 1, but I would still consider this a moderate. I wouldn't consider it strong. I wouldn't consider it weak or no relationship, but moderate. All right, and for number 3, it says, which scatter plot would have a correlation coefficient with the highest strength? Okay, so the highest strength has nothing to do with direction. That direction is positive going up or negative going down. Strength is which one is more compact, which one is closer together, which one has a closer relationship. So the one that has the highest strength and is more compact is going to be A. So just a reminder, we're talking about correlation coefficient means two things. It means that it's going to represent the direction and the strength. Now, I've given you just 2 random correlation coefficients. Pause the video and write down those relationships that these have and then check your answers. Alright, so looking at the first one, I have R equals negative 0.89. So if I have negative 0.89, that's going to tell me 2 things. It's going to tell me that it's a negative direction, because the negative number, and 0.89 is closer to negative 1, so therefore this is going to be negative and strong. And I kind of think about this as money. So 0.89 is like change. It's closer to the 1, so the closer it is to 1 or negative 1, the stronger it is. Alright, for the second one, I have R equals 0.25. So 0.25 is going to be a positive number, but 0.25 is closer to 0, so I'll consider that positive and